everyone doing? I know that there's not so good, not so good. Feeling, hey, that's good. How many of you guys are nervous about Printf? Okay. How many of you guys are nervous about memory allocation? Well, good news for you guys, you don't need it. Turns out that you don't actually need any kind of memory allocation for building Printf. I was very confused when I looked at my past live code and found that I didn't have any memory allocation. And I'm like, well, that's weird. Maybe I just skipped it. So today I looked back on my old code. My old code ran without any memory allocation. And I'm like, that's weird. Maybe we just didn't use memory allocation. So I looked at my friend's old code. My friend's old code also did not use any memory allocation. And I'm like, wow, that is strange. Turns out you actually don't need it to run Printf. You can use it if you want to do a different way of doing things. But today I'm actually going to show you a simplified version that does not use memory allocation. We see each other? Yeah. Now, if you'd still like to learn some memory allocation, that's okay. After we go over Printf, we'll be going over singular linked lists, which does use a little bit of memory allocation. Sound good? All right, so to start us off here, we're going to go ahead and go over our header file. I've got a couple of libraries here to help me out. I think you guys only get the standard library, but I'm not sure. You guys have more information about that. I use these to kind of simplify my live code. We'll show a little bit later. This is kind of a really big part of things. Oh, I had a whole slideshow. Love it. Hold, please. I was so focused on getting the code up and running. Really quick, are there any questions to start us out? No? No questions? I can work with that.
Just confirming, even though it says we need to do memory allocation on a project.
Not to my knowledge, and I ran up here the second that I realized to talk to Nicole about it and told her, hey, we didn't use any memory allocation. She seems to be in favor of not needing to use memory allocation. So I would definitely check in with her, but you're not going to lose any kind of memory. If you run Valgrind, it's not going to come up with any kind of errors. Hi, Nicole. Blend into the bricks. Do you have any comments on whether or not they need to use memory allocation for Printf?
Technically, no, because I thought about this earlier, and I'm like, but once you print something, like, you don't need it, that's a valid. So,
Yeah.
no, you don't need to use memory allocation.
Yeah. So, okay, let's actually go through the slides, and then we'll go through the header file, and then we'll go through the code. We're going to speed run this, so that way I can also give you guys some singly linked lists. So Printf in a nutshell, seriously guys, don't freak out. Really quickly, you guys should all have partners by this point, yes? Anyone not have a partner? Fix that very quickly. Okay, good. So super important, if you haven't talked to your partner about work schedules and what it'll look like co-working with them, either if you guys are synced up and you're able to sit next to each other in program, or if you do a baton pass and you say, hey, all right, I just finished this step, now it's your turn, get to it when you get off of work. Have you guys done some GitHub practices with your partner, passing things back and forth to them? No, you haven't. Okay. So one of the first things that you're going to want to do, if you haven't done it already, is open up a text file on your side, save it, push it to GitHub, have them pull it, have them make an edit, have them push it to GitHub. You pull it, edit it, push it. Everyone good with that? Awesome. All right, so what is Printf? Printf is a periodic function which prints a string in standard output. It takes format specifiers with variables respective to the order received. For example, printf, you open up your parentheses, you put in a little quote, you close your quote, then you put in various arguments such as variables that you might have. If you want to dynamically print out various numbers because you want to know what x equals at a certain point, this is what you will use for what we call debug prints. You might have already used it. Congratulations, now you get to build it. This means that we need two things, a way to look through the arguments and a way to choose which of our functions to use in the case of characters versus strings versus integers. How does your program know that it needs to print a digit? How does your program know that it needs to go through a string and print each character? You also need the functions for printing variables, but that's your bridge to cross. I will not be covering it, and it is so much easier for you guys because you have access to the standard library. I did not. So it's not actually too big of a deal for you guys. You're getting a little bit more bang for your buck today than I got back in my day. It'll be useful for yourself and your grade to build a flowchart. Do you guys know what flowcharts are? Very good, very good. All right, so the main show. Start with an understanding of the variadic functions. How comfortable are we with variadics? So?
We just covered them like.
Yeah. So that was when I was in school, when I was in you guys' spots, that was the assignment that I just didn't do. So going into Printf, I was very confused. So VA start, it initiates the beginning of looking at our arguments. VA end, it denotes the end of our arguments. Shocker. VA copy, this creates a copy of the variadic functions. I don't believe that we used this in my Printf, but it is there as an option. And VA arg will help you access the next argument in your list. Now here's something important about the variadic functions, the way that they work, and we'll get into this a little bit more later. Once you use VA start and VA arg, you cannot go back to the previous argument. So, use what you need. You're okay. When you start VA start and you use VA arg to go to the next argument, you will not be able to go back to the previous argument unless you have saved that, the entire of the argument. Now that's where you would need memory allocation, but you don't actually need it. We'll get into it. All right, so what's next? Detecting the format specifier. Again, how do we know if we're printing a digit? How do we know if we're printing a string? How do we know if we're printing a character? How do we know if we're printing a percent sign? How do we figure out what format to use? This is an example of Printf, right? And you can see all of the format specifiers there, and it includes all of the variables that it wants to print out at that point. You'll need to search the string for the format specifier, which is preceded by a percent sign. So are we following so far? Yep. And what function do you have access to in the standard library? Tutor. That is how you will search for your percent sign. You're going to look for, Yep. All right, so where do the args fit in? Depending on how you have your main function set up, you'll need to use the functions that we talked about earlier, your variadic functions. Using VA list, the data type for the arguments, VA start, VA args, VA copy, and VA end in your main function, you'll be able to access the trailing arguments one by one. If you're not super familiar with the variadic functions, you'll want to start practicing looping through and printing the arguments if you don't already know how to. We'll talk about how they fit in the loop here in just a moment. Super quick note, Printf should return the number of characters that it prints. If you're using Tutor, Tutor already returns the number 1. If you're using homemade Tutor like we did, it might not. That was a really big problem when I did Printf, because I used homemade Tutor and my friend used store-bought Tutor. So our number counting was completely wrong. Determine with your partner how to calculate these things. Consistency is key when you are bug hunting. If you are calculating the number of characters printed in the loop, or if you are calculating the numbers printed when you print it. That is an important concept. Quick kitty break. This is Raylu. She's my beautiful white kitty. I woke up the other morning and she was just laying completely across my tummy. And that's Mayhem. Mayhem's a little stinker. She keeps knocking stuff off my desk and was trying to get into my partner's hot cocoa this morning. Any questions so far? Yeah, what's up?
I don't have a question on this, but as far as making sure like inconsistencies, like with your homemade chart, just be sure you have some sort of uniform way of documenting how your function works.
Yep.
And make sure that's like it's easily accessible, so that when you're bug hunting, you can go and like be like, oh, this is returning this, but its documentation isn't correct. You know? Yep.
Documentation is especially important when you are working with partner projects. If you don't have a way to communicate easily with your partner, that is generally done with comments. If you're not commenting your code, you are being a bad partner. I was a bad partner. My comments came out to be commented out debug prints, and my partner had to sit there and figure out what I was talking about. God bless her, I love her. She's an ARVR now and she's doing great. All right, we have the format specifier. theoretically. What function do we use? This is how to build a get func. This is what I was just about to show you when I was showing you code. This is your struct. Are we familiar with structs? You guys were pretty confident about structs when I taught you last week. The struct is a very simple one, consisting of two parts. The first one holds space for that format specifier. That's the C, the D, the not E, %. And the second part holds a space for a function. Are we all familiar with function pointers? So.
Yeah.
Yeah.
2 weeks.
2 weeks ago, exactly. They kind of smash you through a lot of information really quick in this curriculum. So a function pointer is very simple. It is a pointer that points to a function. You will end up having a code that'll find which function corresponding to the specifier. That function will grab the function and give it back to you. That's our get func in a nutshell. So time to set up our functions. The struct we created allows us to easily build an array in the format of specifiers and the respective functions. It'll look something akin to this. So our struct individually will have a C and print char. That'll be our function pointer. We'll have another struct, S, print stir. That'll be another function pointer. D, print int. Follow so far? Yep. Awesome. We're almost there. You're going to loop through your new array. Once you find your format specifier, you're going to loop through your array of your functions. And use the format specifier that you found earlier to determine which function you want to use. You then return this function back to main, where you can now pass the next argument into your determined function. Making sense to you so far? It's a lot of info.
Are you using multiple functions for the program, or are you just building it in one?
You are ideally going to be putting it in multiple files with multiple functions.
Okay, because I've seen it where they just use one struct with the format specifier and then loop through that, and it was just like in one.
So there is one function that'll build that array for you. Here. That is a function that happens upon initiation, if I'm remembering right. Either that or it happens when you call for the get func. We'll take a look at it here in a second. But if you're talking about the code that builds this array, that is one function in and of itself.
Right.
And then it points to a bunch of other functions that do the print char, print stir, print.
Gotcha. So you break them out partly.
Yeah. And you can take all of the print char, print stir, print int, and put them in their own file. You'll see that later when I do the code for you. All right, last chance for questions. Any other questions so far? And I will give you guys a chance for questions when I am programming, I assure you. It's not actually
Let me see the code.
Once I close this PowerPoint, you will not have a chance.
No more.
All right, final thoughts before we get to the code. It's just a few more things. I promise this one is important. This project is not the end of the world. Biggest takeaway of the presentation. If you don't listen to anything else, I want you to listen to this. This project is only worth 20 to 30% of your grade. Talk to your instructor to confirm. Talk to registrar and student success about whether or not this will be a prerequisite for you. If you can take a little bit of that pressure off of yourself, do it. Manual reviews are nothing to be afraid of. I'm not sure if it's confirmed yet, but what we did was we ended up having to present our code to a student tutor. If that ends up being the case for you, don't be scared of it. Student tutors grading you, want you to succeed. Lean on each other as you work. Now is the time to build a network. Don't just lean on each other because you need each other and you want to help each other out and you want to find the answers that other people have come up with and you want to collaborate like good programmers. Now's the time to figure out who is going to be in the workplace with you. Who is going to enter the tech sphere with you. Seriously, guys, do not panic. All right? Thank you.
I'll do what I want, Ace.
You know what?
Panic if I want to.
Panic, I don't care. It is not going to be to your success, though. All right, let's get into the programming. Here's what you all came from. So, header file. You guys have seen these before. You've worked with these before. We've got our struct format. That's what I was talking about earlier. You've got your format specifier, or rather a spot to hold what will be the format specifier. And you've got your pointer function, right? So that struct is kind of the blueprint for what you will end up creating. We've got a get func function. That's going to be what finds the function pointer that we use. Int printf, the int is the returning of the numbers, and then printf itself, you guys know. The ... here is what signifies that it's a variadic function. We've got print char, print stir, print int, print %. You guys will see that later as well. So let's go ahead and go to main.c. Do we have something else that we want our function to print? When I did this the first time, they had me print skibidi toilet. Yeah, really.
Do it again.
Are you guys gonna make me print skibidi toilet, or do we have something better?
We have respect for ourselves.
We have respect for ourselves. All right, well.
Don't panic.
Don't panic. I like that.
What is drive that panic? Skippity toilet.
That's so easy.
It was pretty rough, actually. All right. So don't, and then we have our format specifier and string, denoting that we are going to print a string, and panic with 3 exclamation points, and then we're also going to throw a new line on there. In Python, new lines happen automatically with print statements. In C, they don't. So, all right, main example. Do we want to start with the get func, or do we want to start with the looping and variadic functions?
Variadic.
Start with variadics. I like that idea. All right, let me open that up on this side. Not that. There we are. Where am I? All right. Oh, are you guys looking at the intermediate example? You guys are looking at the version that already has code. You're not. Okay, there we go. So we're going to go ahead and set up some variables. Func error check will make sure that our function is returned without error. Format print holds the function we'll use later. Func print, not format print. VA list will hold our arguments. Understandable so far? I'm moving on. I don't hear anything else. So VA start. We start iterating through our arguments. This is the start of the variadic part of the variadic function. Check to make sure that we have input. If no format, then printf. What do we want to print? This is a debug print. You guys can use debug
error.
prints.
So you're doing if it's an error, right?
Error.
So yeah, just do error and valid and format insert or whatever.
Sorry.
There. And then we return 0.
Are you allowed to use Printf?
I was gonna say, I thought the word said you print
For
it.
error checks, if you are debugging, then you can use printf.
Gotcha.
You wouldn't be able to use that necessarily here. Instead, you would simply return 0.
Right.
Do we do it, I was thinking C#, we did like long error codes that we could, I
Yeah,
don't know.
There's P error, but
from what I understand, C actually, if you get really deep into it, lets you make your own error codes.
yes.
So, but that's a bit advanced. So, moving on. While we do have format, it's not equal to null. We're going to check for the format identifier. If our current format, this is the current character that we are in our main argument, is equal to the %. We open up our brackets, we grab the next character as it's going to be the specifier. Format plus. And then if there is no format,
Sideboarding is so much better.
where am I? Then we'll go ahead and print our error code. You guys will not print your error code, but I'll print an error code. What do you want from me? All right. Now we're going to go ahead and put in the call to find our printer function. Func print. There we go. It's equal to get func. Open it up and format. Okay, so now we are calling the get func. Do we want to jump over to get func and see how that works? Yeah, seeing nodding heads, sounds good. Some of this documentation comes from my previous partner, Clay. If you ever meet Clay, she's in T5, ARBR. She is a queen. Tell her that you love her documentation. Right. Where is my get func done? Here it is. So we have our void get func char format. We list args, which means we are going to be passing arguments into the function that we will be getting. If I'm remembering that right. It's been a year since I've done this, guys. Okay. So here is where we build up that array, like I was telling you. Let's see here. So first we're gonna go ahead and start with C. And this is, again, print char. So you see kind of how that works. We've got the format specifier, what to expect, and then we've got the function itself that we're going to pass it, right?
Where did the forms come from?
Forms, that is an excellent question. Let me pull up my header here. So that is from our struct format. We refer to the format as form.
Okay.
Yep. So, and then forms is what we will end up returning. Yes? No. Anyway. No. Excuse me. That is bizarre. All right, I don't know why my blinker went to that, but we are working with it. So next is gonna be S, and we're gonna say print stir. There's that. I just been formatting. The good thing about C is that these indents don't actually matter all that much. Oh my goodness. In C, you can actually put everything in one line if you wanted to. It's not ideal though.
Okay, yes and no. If you're using the actual function blocks, you can, but if you're used to doing like single line blocks, you have to manually add the function blocks to them. Otherwise, yes. It's weird. C acts like a compiled language, but sometimes like it treats it as a interpreted language. It's weird.
I actually cannot confirm or deny that. I'll have to ask a while to get back to you on that. Okay, why is it doing that actually though? Yeah, that's annoying. Alright, so that's gonna be 10%, because we kind of need a way to know. Right. We need a way to know if what we need to print is just a percent sign. Make sense? And then if it's null, then we print null. Bam. Done. Yep. We initialize our iterator because we are going to be iterating through our struct of structs, or rather our struct of form, our forms. Iterate through the struct to find the format that you need. So while the form that we are in, if it's the first form, and it does not equal null, so until we get to the end here, if we are in an actual form, and if our form is equal to the format, we will return that function to the function. So return, I don't know why I'm caps here. Heck. Forms I dot F. Does everyone understand where we are at right now? Any questions so far?
How can you use a while loop instead of a for loop?
I like while loops.
Ah.
That's it. I just like while loops. You do have to remember to iterate them. But I don't know. I feel like while loops are a little bit more flexible than for loops. Even though for loops self-iterate, I just like while loops.
Just make sure whatever way you end up using them is consistent if you find.
Yeah.
I'm saying that to you guys. Be consistent.
Wait, the .f is
.f.
forms .f. I
Return the down function to.
There, where your cursor is.
Yes. I'm trying to remember. Where's our .f? Is it
That's not in this structure set.
Oh,
Yeah.
there it is.
Yeah.
Okay.
Yeah. That's our main example. That's our get func. Do we understand get func all the way through? Yep. It is that easy. It is genuinely that easy. And this is like a third to half of printf right here. Feeling better about printf yet?
Yes.
Good. That's the goal. All right, let's head back to our main example. Func print, get func. Let's assume all of that went well and we've got our get func. We've gotten our func. If we get the print function, we'll use it. So if func print is not equal to null, I'm going to reset VS Code after we're done with printf and before we get to simply linked lists. So if func print is not equal to null, then we will go ahead and refer to func print, which is the function that we got back, and we'll pass in our args. Very nice. Else, if we have not come across a format specifier, which means that we don't end up doing any of this, we're just going to print the character. That's actually going to be putjar. Oh my gosh. All right. Okay. Putjar should work. It should be in one of the libraries that I brought in. All right, don't forget to iterate. And we finish up using the args and return to the rest of the program. Yeah? That was like 30 minutes. Whew. All right, how do we feel about this?
What's the header page
Header?
again?
Yep, I can show you the header. So we've got our start, we've got our void, printf. You guys may be wondering where these are. I hear you asking the question, where are those from, Ace? You didn't show us. Hey, Ace, what's in that do not show folder? Did you think I was going to give it all to you? Did you think that you were going to get everything? No. My print char uses printf. My print stir uses printf. Why? Because I get to use printf.
Got him.
So let's actually cd the and we are going to gcc. Yeah, what's up?
Is the quick chart you're using the one that's actually built into the standard input output?
Yeah, that should be the store-bought putjar.
Okay, I think you've done that one, you may have bubbled that one for it. Because I don't believe it takes a format specifier for, I believe it just takes a character as its input and it takes one.
You are absolutely correct. Character as is. That was also how I ended up doing. Oh, I remember, because I was letting myself use printf. It's fine. In that case. I would have found it when we tested it.
Not
Let me fail in front of people, Brad. It's okay. I'm not afraid of failure.
No, you're doing good, you're doing good.
Let's see. Yeah, that should work. Alright, GCC. You want to do our get funk? Our main example. Pull in name dot c name dot h. Are those all the files? Yep. Oh, I need my do not show. Where's my do not show? Yeah. Ah, it's hiding from me. Do not show, and we're going to say dash o, tester. Yeah. All right. Time to bug hunt. That's in our get funk. Oh, it's because I didn't save any of this. Sometimes that is your issue.
I literally worked out a CSS thing and I was showing up for 2 hours.
Yeah. Okay.
That's bad, that's.
This is far fewer errors. Here we go. Main example, there we go. And then line 40. And we need a little. Print args. That's in our main example. That's line 47. Okay.
So picky.
Yeah. All right, we got our tester. /test. Don't panic!
Yay!
It is genuinely that
Nice.
So- all right, any questions? We feel good about this?
You sent out the repo, right, on the
Yes.
Discord?
Yeah. In fact, I will go ahead and get to erase later. So what I'm gonna do is I have gone ahead and printed everything as it is. That is already pushed. However, I do have it set up where in the main folder, I will probably go in and erase everything that we just did. And under actual code, you will see the code that I've been referencing during this live code. So if you want to try to follow along with all of the links, with all the links that I just had and all of the documentation and whatnot, awesome, you'll have that available. If you want to look at my code specifically, you'll have that available too. All right.
How do we get to it?
That's a good question. If you guys are on the Discord, I've shared it with you on the T2 channel.
Yep, I just pinned it in the T2 Discord chat. If you're not on the campsite Discord, get with me.
If you're not on the campus, where will they be able to get to this repo? So I will also go ahead and put the link for the slides that I made in the same repo. I'll throw a little readme in this one specifically. That's already in there.
Nicole, can you send the links out as an announcement to the class? Will you read mine? Yes.
And then there's also a Blackboard into the student services board, there's a Tutor Talks page that has like all the past slides.
I don't know that.
Yeah.
That's nice. When did you start doing that?
This term,
Oh, ow!
I'm telling y'all gotta look in there.
I would if I could. Alright, let's take a little 5-minute break as I get set up for singly linked lists. You guys feeling good so far? Yes.
Also, I don't know if these are streaming good on YouTube.
On the Atlas YouTube channel, you can watch these. We are currently streaming live right now, actually, which I forgot to say. Hello to current streamers and future watchers. Hope you're enjoying the double feature. We are halfway there. That's not the same as. You guys are watching. No, choices. Loading dog.
At this point, it's like, I start wondering where you guys are at.
Yeah, it's been even longer since I did. No.
Sorry.
You're okay.
Sorry, where is it on Discord? I'm sorry.
It's in the T2 channel.
T what?
T2.
T2SP25.
Alright, delete these garbage. Yes. T2 summer 25, yes, I believe so. I don't need to delete it. Alright, I'm not deleting it. Very good. Okay. I come down here, like,
Oh, I see it.
very good. Very good. Is that, is this the actual clip? Did I not delete
I do have a couple of
stuff?
but I'm not just
Oh.
I know I'm very kind of sweet.
Oh, it's because I am in the actual clip. Okay, here we go. Put that on this side. We don't need an example, we don't need good font, we don't need name, we don't need page, we don't need show. Start with color again.
Over here, aren't they? They just, you know,
Outline. Matey. Robot header. Robot report. Very cool. Very cool. Okay. Have you guys gone over singly linked lists yet? No. That's right, because you're doing Printf right now. Singly linked lists is next. Say again?
Where, that image, where do I recognize that image from?
Cyberjuice.
Thank you. I spent my consciousness, I don't remember where, but yeah, I've seen that so many times.
You've seen her. She's in your dreams. Can I not zoom in here? Okay. Oh, I can do that. Very nice. Alrighty, so who's ready to make a robot army?
Yes.
Yeah, yeah.
Finally.
All right. I love hearing
I
that.
am legend though, and that's scary.
Nice.
All right. So I love robots, and I have some robots that you guys might have heard of, and some robots that you probably definitely haven't heard of. That's okay. I'm a little nerdy. I'm a little niche. You'll have to forgive me. So let's go ahead and create our structs. You guys are already pretty familiar with structs, right? So we have type def struct robot A. We've got a character pointer for the name. We've got an unsigned int for the age. We've got a character pointer for the catchphrase. And this is super important. We have a pointer for next. This is what is going to allow our robots to point to each other. This is how we create a line of defense. Make sense so far? So starting out,
Real quick.
Yeah.
You have struct robot A next, so are you have a struct, is it a struct within a struct, I'm assuming? In the code?
okay, sorry, say again.
You have a struct after the next pointer.
So that's because you're going to be pointing to a struct. Your pointer points to a struct.
Okay.
So
You
if
haven't
this
built
is,
the struct yet. Okay.
if this is your robot, if your robot is a struct, your robot is already built to point to
Gotcha.
another robot.
Okay, that makes sense.
Okay, cool. So this is motherboard. Motherboard starts out by pointing to null. Make sense so far? Now, we don't want motherboard to be without a robot for her army, so we're bringing in Wally. Wally!
I love Wally so much.
Isn't he great? I love him.
My son cried.
So it turns out I missed a step. I missed a part. So first, we go ahead and find our head. That's going to be motherboard. This is a pointer that points to the beginning of the currently empty list. So she is currently pointing to null. For our purposes, we're going to call our head motherboard and set her to null. So when we initialize our list, we are initializing a head node. Currently, she is pointing to null. All right? Then we create our first robot. And we'll create a, hey, excuse me, I wanted you to. No, no, my secrets.
You can edit that out with the stream.
It's fine.
My secret.
It's fine. Okay, so to create our first robot, we will create a program to give fields to our aforementioned struct and then assign it to the beginning of the list. We will go into code that in just a moment, but from a conceptual high up level, that's kind of how this works. We're gonna shrink this just a wee bit if you don't mind. We're gonna move this out of the way if you don't mind. All right.
A little bit, but okay.
Well, you know what, that's fine. I don't actually care. All right, so we are going to have Wally point to null, right? Because Wally's gonna be the end of the line. Wally, move. Sorry, Wally, I didn't mean to be rude there. So, Wally now points to null. Make sense? And then we're gonna have motherboard instead point to Wally. Okay? So when we create our robot is able to have a pointer to what would be another robot. We don't have another robot, so it's pointing to null. Then we update motherboard to point to our first robot. That's how we add a robot to the beginning of the line. So we're actually gonna move. OneNote was not this messy to deal with when I first did this code. Why are you so hooked on this? Come on, OneNote. Work with me here. My apologies, please bear with me.
I never want to work when I need it to.
Yeah, no, never. Okay. I would like to move the rectangle as well as null, please. There we go. Okay. Move. Yeah, we'll get ourselves a little bit of space here. Okay. Wally points to null, motherboard points to Wally. Makes sense so far? Awesome, let's code it. All right, so let's go over our robot header real quick. We've got our struct, and this is the one that we are currently going to be coding. Robot S, that is our robot. Add robot to the beginning, meaning it will return a robot. We've got motherboard as our first argument. We've got our name, our age, our phrase. Okay? Cool. Main C, so we end up calling, let me grab the code on my side. Yes, very good. Okay. Yes, okay. So we're going to go ahead and initialize motherboard, set her to null. We went over that, yes? So here we go. We're going to go ahead, printf, which you can use the regular printf, I imagine. I don't know, I haven't seen your assignment. Adding robot. Wall E. Then give her ourselves a new line, close our quotes, close our parentheses, end with a semicolon, lesson, and then we're going to call add robot beginning, which we are about to program, and we're going to pass in the address of motherboard. Does anyone have any idea why we would do that? Why do I have two motherboards? Why is one of my motherboards like that? Yeah, okay, well, that's fun. We'll figure that out later, I'm sure, if it's an issue. Small e. Now, why are we passing the address of motherboard in? Does anyone know?
I'm not sure.
Isn't that the main thing?
The main thing?
The main
The main thing.
address?
Yep, that is correct. So we are passing in the address of the motherboard, so that way we can take a look at what exactly she is pointing to. Because if we reference motherboard, we're going to reference directly what she is pointing to, rather than the address of her, so we can see. Does that make sense? Pointers. It'll make a little bit more sense when we program our frontline creation. Okay, so first we check if motherboard is equal to null. We want to make sure that we've got a motherboard. And that's one of the things that we need to check. One of many things. So if she is returning to null, then we are going to return, return null. I'm gonna close that. Okay. And if she is not, then we're gonna go ahead and create a new robot, and we're gonna set it to null. So robot S and new robot. Null. So what are we doing here? You guys are familiar with structs, and you guys are familiar with pointers. Do we know what we're doing? Kind of, sort of?
We have our struct.
Yep.
And then new robot, like kind of like an object.
Mhm.
And then that equal to null.
Yep. We are creating a new robot, and we are just setting it to null. Right. So now is where we get into some malloc. You will actually need a little bit of memory allocation for singly linked lists. So we're going to say new robot, and that is equal to malloc size of robot S. Awesome. Make sense so far? Yep. Awesome. Yep, okay. Check to see if we have the space available. If not, we're going to go ahead and return null. Pretty basic stuff so far.
Sorry, did you set the size for robot S to begin with?
Yes. So we are checking to see if we have space for the struct.
So, I mean, was it robot S on your, I thought it was robot A, sorry, is it robot S on your picture?
Let's take a look. Am I at the right place?
No,
No.
the one with the well, it's a picture of the motherboard, but it's the one with the,
Oh, you're talking about my secrets?
I don't know. I don't know, the one that's, you made the struct for robot Charlie in age, but I thought it was robot A, sorry.
Over here?
Yeah, but this is
Yeah.
robot A. Oh, and then you have robot S at the bottom. Okay,
Yep.
I can see that.
Yep. No worries.
Okay.
All good. All right, so we check to see if we have the space available. If not, we return null. Okay. Sorry, guys. All right, so we have space for the robot, but let's make sure. Excuse me. Hello. Let's make sure that we have space for everything else, as well as the null terminator using *. So now, if I'm remembering right, there is a different function that you can use. None of that is what I need. It's because I'm calling it the wrong thing. There's a different function that you can use that'll do the memory allocation for you. I just like making my life hard for myself. So, Malik, Sterlin, and name, because we got the name passed in, +1, that's for our null terminator, and semicolon, new robot, dash, catchphrase, which we got passed in, so once again equal to Malik, Sterlin. Yep. Nope. Phrase. Close that. +1 for the null terminator. Close the parentheses. Semicolon. If we do not have the space, we gotta free the robot. So we free. New robot. Name. Close semicolon. Free. Why? Hey, excuse me. Free. New robot. Guess what I didn't do that I said I would do? Reset VS Code. Catchphrase. Parentheses, semicolon. Free. New robot. And I know that we are going slightly over time. I appreciate you guys being patient. And then we return null. Awesome.
So it's taking away the memory allocation.
Yes. So because we don't have space for anything else, we're just gonna free everything. Goodbye, robot. You no longer exist. What's up?
Why do you have to like free the name actually?
So if you end up having space for the catchphrase but not the name, then you're going to need to free both. If you have space for the name but not the catchphrase, then you need to free both. Now, realistically, you could say new robot name Malik and then do the new robot name equal null check and then free it from there if that comes back null, and then you can do the same thing. But this is just kind of the way I did it. I just like how this looks. All right, we're almost there with this first one. We're going to assign all the fields for the new robot using stir copy or otherwise. Stir copy. New robot. And we're going to reference the name specifically. Awesome. And then the name. And stir copy. New robot. Reference the catchphrase. And phrase. Parentheses, semicolon. And then we didn't necessarily have to do any kind of weird stuff with the age because it's just an integer. Age is equal to age. Awesome. Okay. Take the node motherboard was pointing to, and then we have our new robot point to it, which we all talked about earlier, right? Because motherboard is currently pointing to null, we want Wall-E pointing to null, and then we're going to have motherboard point to Wall-E. Now, what happens if motherboard is already pointing at a robot? We have the robot that we're adding, point to that robot, and then we have motherboard, point to that robot, to the robot we just added. Make sense so far? Otherwise you lose robots. That's not fun. So new robot next. This is the robot that we just added, and this is the pointer for the struct. This is the pointer in the struct for the struct that is going to be the next robot. Yeah, yeah. It's equal to the pointer that motherboard is pointing at. Does that make sense? Yes, I'm gonna assume. Okay, now that we've updated our list, we're gonna update motherboard on the situation. So the pointer that motherboard is pointing to is now pointing to our new robot. And then we return motherboard after her update. turn. Motherboard. Close parentheses, semicolon. Semicolon. Why is that there like that? Okay, got it. Very nice, good job. No compilation errors from what I can tell, so we are going to continue to move forward. We're gonna save that so I don't run into that same issue again. Awesome, all right. So let's go ahead and just add a little printf here. Added successfully. Awesome, okay.
Semicolon. Semicolon.
Ah, good catch. Can you tell I've been programming in Python for the past year?
Save.
Same with linked lists, there we go. Okay, GACC. We need the frontline robot creation. We need main.c. And we need our robot header. Okay. I think that's all we've done so far, -o, first robot. I don't need a quote there. Okay, // that compiled perfectly, happy to see that. Adding robot, well, added successfully. All right, so we've added one robot. Now, I know that I've kind of run you guys a little bit past where you were expecting to go. Technical issues got the best of us. Do you guys want me to continue to show you more robots? I will not be offended if the answer is no. You guys are tired, car crashing.
Ready.
It's okay.
I still have a question on the motherboard's pointing to null, the robot's pointing to null, then you make a new robot and then the motherboard is pointing to the robot and the robot's pointing to the motherboard?
No, the robot is now pointing to null. So robot next is pointing to where motherboard is pointing to. They're both pointing to null at that point, right? So this right here, motherboard, since we're dereferencing the pointer. So we're looking at where motherboard is pointing at. So now new robot next, that's the end of that struct that we had just built, is now also pointing to null.
Okay.
Then we update motherboard to point to the new robot.
Okay, so that gives us room to add a new robot after that.
Yep.
Okay.
Yep. You got it. Okay. Well, for the sake of recording, Caroline, do you want me to just continue the live code or? Up to you. I feel like that was great. Yep. You guys got a little introduction to linked lists? Feeling somewhat comfortable about that?
It makes sense visually, like, okay, now you would.
Now you can see kind of what's going on.
I at least understand more than I did 20 minutes ago.
Yeah.
Hey, that's good. I'm glad to hear that. So
That's a win.
that is a win. Okay, cool.
You could take any lingering questions.
Yeah, do you guys have any last minute questions about this? And the entire repo for this is also available in the same folder on the same GitHub. What I can do for you guys is I can record the full presentation that I had with all of like the robot characters. The reason why we had to do a double feature today was because of some scheduling conflicts.